In this video, we will discuss about Rayleigh distribution. Rayleigh distribution. So this is also a continuous probability distribution. Continuous probability distribution. So we define this as let x be a continuous random variable. Continuous random variable is said to have a PDF of a Rayleigh distribution with the parameter. So we define the parameters as sigma, which is known as the shape parameter. This is the shape parameter. Then the PDF of this distribution, which is defined as fx is equal to x upon sigma square e raised to the power minus x square upon 2 sigma square. So here x is greater than 0. So this is the PDF of a Rayleigh distribution. So PDF of Rayleigh distribution, which is defined as fx equal to x upon sigma square e raised to the power minus x square upon 2 sigma square. So now we write down as the Rayleigh distribution Rayleigh distribution is the special case of Weibull distribution. We have already discussed Weibull distribution. So this is the special case of Weibull distribution. So we defined as with a scale parameter of 2. So when a Rayleigh is set with a shape parameter sigma of 1, so it is equal to the chi-square distribution. So this will be discussed later. Chi-square distribution with the 2 degree of freedom. Now we write down the applications of Rayleigh distribution where we use the Rayleigh distribution. So applications of Rayleigh distribution. So Rayleigh distribution have very wide applications. in real life. So we write down this distribution have widely used in. So we use this distribution because applications is necessary for any distribution where we use a particular distribution. So first is communication theory. So we use this distribution in communication theory to model multiple paths multiple paths of dense scattered signals reaching to receiver. Second, physical sciences. Physical sciences to model wind speed, wave height, and sound and light radiation. Third, we can use this distribution in engineering. Engineering to measure the lifetime of an object where the lifetime depends on the object age. Depends on object age. Fourth application. So basically, we can take the example in engineering first, where we can apply the. So we write down as for example, resistor. Second is transformer. Third one is capacitor. Next, capacitors in aircraft basically use radars, etc. So next to the fourth one, we write down first one we have communication, second we have physical sciences, third is engineering, fourth is medical sciences. Medical science. So in medical science, to model noise variance, in magnetic resonance imaging. That is MRI. So we have very wide applications of this Rayleigh distribution in each field. So now, after writing the applications, we move to the mean and variance. So we calculate the mean and variance of Rayleigh distribution. Mean and variance of Rayleigh distribution. Mean and variance of Rayleigh distribution. So first we obtain the mean or expected value. So what is the mean or expected value? So that means mean is equal to expected value. We denote it as E of x. This E of x we take as integration. So when we take x greater than 0, so that means limits will be 0 to infinity. So x 0 to infinity, x into fx dx. So this we can write our integration 0 to infinity x into fx. So what is the PDF of this Rayleigh distribution? So this will be x upon sigma square e raised to the power minus x square upon 2 sigma square into dx. So now we integrate this. So for integrating, we take 1 upon sigma square from outside the integration. So this gives us x square into e raised to the power minus x square upon 2 sigma square into dx. So we use the substitution. So let x square upon 2 sigma square is equal to t. So 2x upon 2 sigma square. So 2 to 2 cancelled into dx is equal to dt. So here we have the value of x square. So what is the value of x square? X square value is 2 sigma square into t. So now when we talk about the limits, so what are the limits of this? The limits remain same. So when x is equal to 0, so this gives us t is equal to 0, and x is equal to infinity gives us t equal to infinity. So limits are remain same. So now we substitute the limits. So then we see that, so 1 upon sigma square, so limit for t which is 0 to infinity. And what is the value of x square? The value of x square is 2 sigma square into t, and e raised to the power minus t into dx. So what is the value of dx? So the value of dx is sigma square dt upon x. So this can be written as sigma square dt upon x. So sigma square into dt upon x. So what is the value of x? X value we can write down as root 2 sigma into root t. Root 2 sigma into root t. This is the value of x. So we here we take common sigma 2 sigma square 2 and sigma square. So 2 sigma raised to the power 4. So this is 2 sigma raised to the power 4 upon sigma square is already there. 1 sigma we have taken as the sigma q into, also we can take as root 2 as common. So root 2 taken as common. So this gives us integration 0 to infinity, and here is root t, here is t. So we write down e raised to the power minus t or t raised to the power 1 by 2 into dt. So this when we simplify this, so this can be written as root 2 into sigma integration 0 to infinity, and this can be written as e raised to the power minus t, and this t can be written as here is 1 by 2. So we can write down as 3 by 2 minus 1, because we are going to use the definition of gamma function. So what is the definition of gamma function? We write down as gamma n is equal to integration 0 to infinity e raised to the power minus x raised to the power n minus 1 into dx. So here what is the value of n? N value is gamma 3 by 2. So the value of this integration is gamma 3 by 2. So we write down as 2 root 2 into sigma, or the value of this integration is gamma 3 by 2. So we can compare this. So what is the n? So this is n. So n is here. So that means this is our n, gamma 3 by 2. So what is the value of gamma 3 by 2? So we know that gamma 3 by 2 value is 1 by 2 into root pi. So 1 by 2 into root pi. So now we simplify this. So what is the mean of this? So root 2 to 2 cancel root 2 times. So sigma, or can be written as pi upon 2. So sigma root pi upon 2 is the mean. So we write down the expected value or mean. So this is expected value E of x or mu, which is sigma root pi upon 2. So this is the mean of Rayleigh distribution. This is the mean of Rayleigh distribution. Now we obtain the variance. So when we obtain the variance, so before obtaining the variance, we obtain the expectation of x square. So expectation of x square, then integration 0 to infinity x square into fx dx. So this can be written as 0 to infinity x square into x upon sigma square e raised to the power minus x square upon 2 sigma square into dx. So here we calculate the value of this. So when you integrate this, so we get the value of this is 2 sigma square. So we take as 1 upon sigma square as common. So this can be written x cube e raised to the power minus x square upon 2 sigma square into dx. So same as previous integration, we use the substitution method. So put x square upon 2 sigma square is equal to t. So 2x upon 2 sigma square into dx is equal to dt. So 2 to 2 cancelled. So x upon sigma square into dx, sigma square into dx is equal to dt. Now, so same limits will be remains unchanged. We have already discussed in mean part. So that means we can write down 1 upon sigma square. So limits for t will be 0 to infinity. And what is the value of x cube? So here we have the value of x square. So x square is equal to 2 sigma square into t. And what is the value of x? So the value of x will be root 2 sigma into root t. So this is the value of x. So now here we have x cube. So we have x cube. So when we are going to write the value of dx, so the dx value will be dt upon x into sigma square. So dt upon x into sigma square. So here you are going to write this x cube as it is. Now here we write down e raised to the power minus t, and the value of dx. Dx is dt upon x into sigma square. So x to x cancelled means x square times. So this can be written as 1 upon sigma square. T is equal to 0 to infinity. Now we put the value of x square. So what is the value of x square? So this sigma square we also take as common. So sigma square we take as common in numerator also. So this sigma square. So now we have a value of x square. So value of x square is 2 sigma square into t and e raised to the power minus t into dt. So now we solve this integration. So this sigma square to sigma square cancelled. 2 sigma square we taken as outside. 0 to infinity e raised to the power minus t into t dt. Okay, so this can be written as 0 to infinity e raised to the power minus t. So here t raised to the power 1. So this can be written as 2 minus 1. 2 minus 1 into dt. So we use the definition of gamma function. So here using gamma function. So when we are using gamma function, so this integral will equal to gamma 2. What is the value of gamma 2? Gamma 2 value is 1. So this is equal to 2 sigma square. So expectation of x square is 2 sigma square. So this is the value of expectation of x square. Now we are going to calculate the variance. Variance is equal to sigma square. Sigma square equal to expectation of x square minus expectation of x to the whole square. So this gives us 2 sigma square minus sigma into root pi by 2 to the whole square. So this can be written as 2 sigma square minus uh, pi by 2 into sigma square. So pi by 2 into sigma square. So now when we simplify this, so this gives us sigma square be taken as common. So 2 minus pi by 2. So 2 minus pi by 2. This can be written as sigma square into 4 minus pi upon 2. So this is the variance. So this is the variance sigma square. So this is variance sigma square. Okay. So here we write down the uh, variance, variance. We can write down in short variance of x is equal to sigma square 4 minus pi upon 2. So this is the variance of Rayleigh distribution. So after understanding the variance of Rayleigh distribution, we will discuss about the moments. So first we discuss about the row moments and the central moments. Row moments and central moments of Rayleigh distribution. Rayleigh distribution. So we write down directly the row moments are mu 0 dash which is equal to 1 and mu 1 dash which is equal to sigma root pi by 2, that is called the mean also. Mu 2 dash which is equal to 2 sigma square and mu 3 dash, this is expectation of x square also, mu 3 dash which is equal to 3 sigma square into root pi by 2 and generally we calculate the first four moments. So this is 8 sigma 4. So these are the row moments and now we are talking about the central moments. So central moments when we calculate, so central moments that is mu 2 equal to mu 2 dash minus mu 1 dash whole square. So this gives us variance. So 4 minus pi upon 2 into sigma square. So this gives us variance. So now when we calculate third moment, central moment, so this gives us root pi by 2 into pi minus 3 into sigma q. And the fourth central moment pi, so that will be equal to 32 minus 3 pi square upon 4 into sigma raised to the power 4. So these are the first four row moments and central moments. So after understanding these row moment and central moments, so we calculate the coefficient of skewness and kurtosis. So when we obtain the coefficient of skewness and kurtosis, so coefficient of skewness, but first we calculate the skewness, that is denoted as beta 1. Beta 1 is equal to mu 3 square upon mu 2 q. So that is equal to pi by 2 mu 3 square. So pi by 2 into pi minus 3 to the whole square sigma raised to the power 6 upon mu 2 q. So mu 2 q means 4 minus pi upon 2 raised to the power 3 into sigma 6. So this sigma 6 to sigma 6 cancelled. So this gives us 4 pi into pi minus 3 to the whole square upon 4 minus pi raised to the power 3. So this is our beta 1. So now when we calculate coefficient of skewness, so coefficient of skewness, that is gamma 1, or gamma 1 is equal to root beta 1. So root beta 1, so this can be written as 2 root pi, 2 root pi and pi minus 3 upon 4 minus pi raised to the power 3 by 2. So this is our coefficient of skewness. Now, kurtosis. So when we are going to calculate kurtosis, that is our beta 2. So beta 2, which can be formulated as mu 4 upon mu 2 square. So mu 4 upon mu 2 square. So this can be written as 32 minus 3 pi square upon 4 into sigma 4 upon mu 2. Mu 2 square means 4 minus pi upon 2 to the whole square into sigma 4. So sigma 4 to sigma 4 cancelled. So this can be written as 32 minus 3 pi square upon 4 minus pi to the whole square. And now we write down the coefficient of kurtosis. So coefficient of kurtosis, that is gamma 2. So gamma 2 is equal to beta 2 minus 3. So beta 2 minus 3, so 32 minus 3 pi square upon 4 minus pi to the whole square minus 3. So this is the coefficient of kurtosis. Now, after understanding the coefficient of kurtosis, we move to the cumulative distribution function. So we now move to the cumulative distribution function. Cumulative distribution function, that is CDF, CDF of Rayleigh distribution. So how to calculate the CDF of Rayleigh distribution? So we know that the PDF of Rayleigh distribution. So on the basis of PDF, we can calculate the CDF. So CDF we denoted as fx, capital Fx, so which can be calculated as integration 0 to x. That means probability of x less than equal to x, x into ft dt, ft dt. So here we have the limit in x, so we can change the function in the form of t. So then we write down this as integration 0 to x ft. Ft means t upon sigma square e raised to the power minus t square upon 2 sigma square into dt. ओके, तो जस्ट द पीडीएफ, हमने पीडीएफ को चेंज कर दिया है किसमें, एक्स से टी की फॉर्म में, बिकॉज लिमिट हमें किसमें दे रखी है, एक्स में दे रखी है, तो वी कैन नॉट राइट इन द फॉर्म ऑफ एक्स एज एफ एक्स. So we integrate this. So when we are going to integrate this, so 1 upon sigma square बाहर ले लिया हमने, तो t e raised to the power minus t square upon 2 sigma square into dt. So now यहाँ पर भी सब्स्टिट्यूशन यूज करेंगे. तो let t square upon 2 sigma square is equal to y. And what is the differentiation of t square? 2t upon 2 sigma square into dt is equal to dy. So 2 से 2 cancel हो जाएगा. So then this can be written as t upon sigma square into dt is equal to dy. So now we talk about the limits. So what is about limit? So lower limit. So first we write down the lower limit. So lower limit. So when we have a x is equal to 0, so that means x means sorry t. So we take the limit for t. So we write down t is equal to 0. So when t is equal to 0, so 0 upon 2 sigma square equal to y. So this means y equal to 0. So our lower limit is remains same. Or for upper limit. So upper limit t is equal to x. So t is equal to x, so this gives us x square upon 2 sigma square equal to y. So y limit will be x square upon 2 sigma square. So y limit will be this. So now when we solve the integration, so 1 upon sigma square, the limits will be 0 to x square upon 2 sigma square into uh, the value of this. So value of this here we have. So e raised to the power minus t. And now we have t dt. T dt upon sigma square also. So sigma square we take inside. So here we otherwise we write down the value of t dt. So we write down the value of t dt. T dt is equal to sigma square into dy. So here we write down sigma square into dy. Okay. Tt we replace by y. So this replaced by y. Y. Okay. So because we take as t square upon 2 sigma square equal to y. So now sigma square to sigma square cancelled. So we have a 0 to x square upon 2 sigma square e raised to the power minus y into dy. So we can integrate this. What is the integration of e raised to the power minus y? The minus e raised to the power minus y 0 to x square upon 2 sigma square. So then we apply the upper limit. So e raised to the power minus x square upon 2 sigma square or minus minus plus e raised to the power 0. So this gives us minus e raised to the power minus x square upon 2 sigma square or plus 1. So this is our cumulative distribution function of Rayleigh distribution. So can be written as 1 minus e raised to the power minus x square upon 2 sigma square when x greater than 0 and 0 when x less than equal to 0. So this is the CDF. This is the CDF of Rayleigh distribution. So hope you understand this CDF, how to calculate the CDF of Rayleigh distribution. After calculating the CDF of Rayleigh distribution, we take one problem based on Rayleigh distribution to understand the Rayleigh distribution. So we have one question based on Rayleigh distribution. So the statement is the lifetime of a certain electronic component follows the Rayleigh distribution with a scale parameter sigma is equal to 100. Sigma equal to 100. So first find the probability that a component lasts more than 150 hours. More than 150 hours. Second, determine the mean lifetime of the component. Mean lifetime of the component. So this is our question. So we understand the question, then we have already mentioned here, follow the Rayleigh distribution. So we solve the question by using the Rayleigh distribution. So we know that, so here we write down as, we know that the PDF of Rayleigh distribution which is fx equal to x upon sigma square e raised to the power minus x square upon 2 sigma square when x greater than 0. So this is the PDF of Rayleigh distribution, and when we write down the CDF, So CDF we write down as fx is equal to 1 minus e raised to the power minus x square upon 2 sigma square. So we have already written over. So this is the CDF. So now we are going to calculate the first part. So here sigma is already given. So given we can write down as given sigma is equal to 100. So sigma equal to 100. So the probability that the component last more than 150 hours. So last more than 150 hours. So this can be written as probability of random variable x greater than 150. So 150, so this can be calculated 1 minus probability of x less than equal to 150. So x less than equal to x, so this can be written as f of 150. जब हम क्यूमुलेटिव सीडीएफ निकालते हैं तो सीडीएफ में क्या लिखते हैं? सीडीएफ हम यही तो लिखते हैं कि एफ एक्स जो फंक्शन ऑफ एक्स है एफ एक्स. So this fx is equal to probability of x less than equal to x. So this can be written as directly 150. So 150. So now here we solve the CDF. So CDF कैसे solve करेंगे? इससे solve करेंगे. अब CDF के basis पे हम इसका solution find out करेंगे. So now using CDF. So when we are going to use CDF, so that means f of 150. So this can be written as 1 minus x की जगह पे क्या रिप्लेस कर दिया हमने 150. और CDF का फॉर्मूला क्या है? ये फॉर्मूला है. तो 1 माइनस ई रेज टू द पावर माइनस 150 टू द होल स्क्वायर अपॉन 2 इंटू सिग्मा. सिग्मा कितना है? 100 का स्क्वायर. तो ये कितना हो जाएगा? 1 माइनस ई रेज टू द पावर माइनस 150 स्क्वायर इक्वल टू 22500 अपॉन 100 स्क्वायर इज 10,000. 10,000 इंटू 2 means 20,000. So 20,000. So this is equal to e raised to the power minus 225 upon 200. We simplify this, the 1 minus e raised to the power minus. So this value is equal to 1.125. 1.125. Now, so when we see that the value of 1 point e raised to the power this, so my e raised to the power minus 1.125, this is equal to approximately 0.3247. So this is equal to 0.3247 by using the calculator. So this can be written as 0.3247. So now we get the value is 0.6753. So 0.6753. This is the value of F150. So now, so probability P. So probability P when x greater than 150 hours. So this can be written as 1 minus so 0.6753. So this is equal to 0.3247. So 0.3247. So this is our answer. So 32% chances are there. So that means your component more than 150 hours. Now we do the second part. Second part means mean time. So mean time, mean lifetime. So mean lifetime is expected value of x. So this is sigma into root pi upon 2. तो सिग्मा क्या है हमारा 100 और रूट पाई अपॉन 2. और पाई की वैल्यू कितनी है हमारी? पाई होता है हमारा 3.14 अप्रॉक्स अपॉन 2. तो 100 into this. So this gives us, so when we calculate this, so this root value approximately 1.2533. So this can be written as 125.33. So the average lifetime means mean lifetime of the component is 125.33 hours. So mean lifetime of electronic component is 125.33 hours.